as we have the 2D model already drawn, we can now proceed to draw the solid. To this end, let's prepare layers that will help you further. We will create a new helix layer. Further, create a thread layer. And here let the color be different, for example, blue. And we will create a solid, so let's create a solid layer. And here we could use such a color, maybe metallic. That's all these extra for now. To obtain the solid, we will need to obtain the outline of this hatched as one closed polyline or as a region. No dimensioning is needed at the moment. We will prepare an outline so that you can indicate points or cut the axes so that they could point down the top of the cylinder, up the cylinder, down or up and the top of the block, and all these elements are superfluous. As we drew this cross-section half-section view, we used such a simplified formula that the hole for the M14 thread is 11.2. This is not entirely accurate, so now because we want to draw a real thread, we will switch the layer to the helix. And we draw the actual diameter of the hole for the thread. This actual diameter is 11.835. So here finally the diameter is to be 11,835. That should actually be the hole. Let's draw a line from the quadrant with ortho on. Well, you can see that we exaggerated a little, so the line was like this, so let's cut this line now. Here still have to be cut. Cut this outline with this polyline. Maybe this hatching still came to us, then let's correct this hatching so that it was up to this line. Then we can throw it in. And this is auxiliary also because we have remembered the greatness here at the end. We will now modify the polyline, i.e. we will attach this one to this polyline and we will do it close. If we have a draw here, it means that we now have a closed polyline, which includes such a solid cross-section. Because we want to create this threaded block yet, we will also need to draw the thread pitch diameter, and this pitch diameter is 12.701. Let's draw it so that it is offset by 1 thread pitch or 2 mm downwards and will have 12.701. This is the so-called thread pitch diameter. We really needed the radius of it, so from the center to the quadrant this is what we really need. And the circle was there to make it easier to enter this value. We need to draw the thread outline. The M14 thread is based on an equilateral triangle with side 2. The shapely figure with 3 sides and a side. Clip no matter where, and because it is supposed to be jumped to, then to. Here we will also need the height of this triangle. We remove it so that the center of height hits here on the pitch diameter of this thread. For this thread to be well cut, we still have to round it. And the radius will be used as 1/10 of the jump, or 0.2 just right. To and we'll say we round here. From this outline a solid must be created that will be dragged along the helix, but for it to be formed it cannot touch each other. Therefore we will shorten this triangle by 0.1. This is sufficient for most thread cases. To cut off the triangle so that it doesn't touch here, and cut it, we don't need it anymore because it was auxiliary to close it. And modify the polyline to close it. As it was drawn, it is a closed polyline now. Because to create the block, we have to operate on objects such that the polyline must be closed or it is a region. Let's verify if it will work well now. So will you cut the thread? Nominal thread size 14. It is here, i.e. there will be a screw, so there is a place, therefore it should screw in without any problem. But here or we will go well. As you can see, everything will cut without problems. We can throw away the auxiliary lines. To create this thread well, we will need the upper position of this radius. So we copy this radius and copy it by an even number of strokes. In this case 44 should be enough. Why it should be like this? Because the thread will start earlier than the solid and end higher in relation to how we will enter the material of the solid. It will be a smooth transition. And now that we have the body ready, we are almost at home. We just need to set the coordinate system. To show the coordinate system and introduce him in this place, we will accept the axis, and as you can see at the moment the coordinate system is inserted here. So far we have drawn down the plane, so the coordinate system was actually unnecessary to us because its location was obvious. However, when we operate on a block, Displaying the coordinate system will be very helpful because we will be able to orientate ourselves in what way we look at a given block. If we are so set up, now let's do such a rotation, that is, we will rotate our body and these prepared thread outlines 3D rotation. Let's say that it is to be the center of this rotation at the end of the axis and around the axis about 90 degrees. Look at it from above in front. So as you can see, it is as solid as if it was standing on a piece of paper. Well, now we can look at it and let's get ready. Let's go back to the helix. And draw the thread line, or rather the line along which you need to draw this thread outline triangle. So the end of this line is asking here and now about diameter. So we have to tell him that this is the end of our pitch diameter. The center appears here because we put the triangle height here, so it shows us the center but be right key end, and then it will show the end of this prepared helix diameter. The end radius of this helix can be accepted as the same because we made a thread that has no thread exit, therefore it will be the same along the entire length. We will set the jump again after 2. We will say that the end of this helix is the A to B. In this place where we indicated an even number of jumps gave us that the helix ends in this place. Now we have the line ready to create the thread, so now let's create this thread. So we will drag the prepared triangle along the helix line. And unfortunately this operation must take a while, but I already have one. Now that it does not bother us when creating the body, we will temporarily hide it. In other words, we'll turn on the solid layer and switch to the current solid layer. For now we will hide it and the helix. And now we'll twist the one you have prepared around the axis so that it is the end, and the end asks us if it should be 360. We can do 360 degrees. And we already have a lump, but you still need to drill holes here. Therefore, we will create cylinders in the middle so that we can cut this axis so that we can now indicate this point. Here we have the end as the diameter of this cylinder, and here we can indicate the height of this cylinder. Similarly, we can create the second right click, and here there was a polyline, the end of this height this. To make it easier to indicate later, we will combine this cylinder with this cylinder. If we click now, they mark together, it is already one block. Now we can drill these holes more. we drill more holes through the rotary array and say that we have to rotate these prepared holes for drilling. And we will say that it is around the axis, and we will point, and here we have a problem, it is not pointed to end. If not, it can still be in the middle, but we have the other end here. Only now it is to be detached, and here enter how many, or 3 or 4, let's assume 4 elements. This is already done. Now if it is unassisted, then each element is separate as if it were combined, then one click would cause that we indicate all the elements that were made in the pattern. And now we will make a difference from this block. We subtract these 4, so we really drill those holes. We ended up with an interrock, and now how it all marked for it is already a drilled block, because now it is a bit poorly visible, so maybe we will watch it in such a view. Let's see that actually this block already is drilled holes. This table next to 3D solids is really unnecessary. Therefore we will hide it. But to finish this block, of course, you still need to thread it, i.e. turn on the thread. And we will make it subtract from this solid, and here it is necessary to indicate. And now that so the piece is lost, it can be seen that it is subtracted, i.e. we have a threaded block. Let's take a look, here it is threaded. What I said was supposed to be higher is for a gentle threaded thread here. And now when we get to this nugget, it is like that. To see better, or to show what a half-section view looks like, we can do the trick. Now we can save as 3D. We will save as a 3D model. We can draw, for example, such a 00 cube as a base point, and now it's just that the cube is higher than the outline can really be, for example 60, and again we will make differences. So we subtract the cube from this solid. Well, unfortunately he had to work a little AutoCAD, and now we see how it is with this outline. Actually, with the block we can say that we don't need this hatching because we can see what it looks like. Here we can see what the thread outline looks like. Now it will definitely be much better. Here the thread began to cut. And here upstairs has nicely started gently. That is, if we look at the front, we have a half view, i.e. what we have drawn on the model. Thank you for your attention.